Students, this is the functions video for October 23rd. You're going to create this Frayer model on functions and then a few more activities on multiple representations and bring this to class on 10/23. We're going to start with the definition on the next slide. Alright, the definition of a function is the relationship between two variables in which one is dependent on the other. Then we're going to move over to the essential. Some of the essential characteristics are, and I'm just going to do them as bullets here. There's exactly one y for each x. X cannot repeat with different y's. Some other essential things to know is that domain is still x, range is still y, and that we can rewrite equations that we've been studying, like y equals 3x plus 2. We can rewrite them in something called function notation, where we replace the y with this, which is called f of x equals 3x plus 2. So these are the same when we go to functions. Equation and then a function is the same. We just switch the y to an f of x. Okay, now we're going to look. These ordered pairs make a function 1, 2, 2, -1, 5, 2, and -2, 0. If we look at all of the x's, 1, 2, 5, -2, they never repeat with another y, so this is a function. Okay? We could have a graph. This graph is a function. Okay? We're going to learn about something in class called the vertical line test. The vertical line test says if I draw lines down, these red lines, see how each time I draw a red line down, it only hits one time? Okay? That means the x's don't repeat with anybody, and that's called the vertical line test. We'll learn more about it next time. We could have a mapping to look at. Remember, these are the x's, these are the y's in a mapping. -2, 1, 2, 5, and -1, 0, 2. -2 goes with 0, 1 goes with 2, 2 goes with -1, and 5 goes with 2. This is a function because none of my x's go with two different y's. See how they all have one line leaving them? So that means they all only go with one y. Okay? The last representation we're going to look at is a table. 1, 2, 5, and -2. 2, -1, 2, 0. And as you look again, none of these x's repeat with a different y, so these are all examples of functions. Okay. 1, 3, 2, -1, 5, 2, 2, 0. 1, 2, 5, 2. Because these 2's are matched up with different y values, this is a no-no. This is not a function. If we look at a graph, and when I draw my lines down this time, you'll see that these lines hit more than one time, and that makes it not a function. Here's my mapping. My x's and my y's. 1, 2, 5, -1, 0, 2, 3. 1 goes with 3, 2 goes with -1, 2 goes with 2, 5 goes with 0. See, this one leaves one time, this one leaves one time, but this one you have 2 leaving out of here. 1, 2. And so that makes that not a function. That's a no-no. Okay, here's a graph. A table. 1, 2, 5, 2, 3, -1, 2, 0. When you look down on this side right here, I see that 2 goes with -1 and 2 goes with 0, and that is a no-no. You cannot repeat on this side with a different y. So when we say different representations, just a different way to show something. Like I could show the number 24 by doing 8 times 3. I could show it doing 23 plus 1. I could show it doing 25 minus 1. I could show it doing 6 times 4. So I can represent 24 in a lot of different ways. That's what this is. It's all about representing these functions in a different way. Okay? One of the ways is just a listing of ordered pairs. So like 1, 2, 2, 3, 4, 5. This is a listing of ordered pairs. I could have a table or a T-chart of the same things. 1 goes with 2, 2 goes with 3, 4 goes with 5. So that's a table. And those are two that we're pretty familiar with, a list of ordered pairs and a table. Mapping is something we talked about here real recently. It's a diagram showing the relationship. So if I have 1, 2, 3, 5, 7, 8, 1 goes with 5, 2 goes with 8, 3 goes with 7. That's what a mapping looks like. And remember, it's bubbles with arrows. A description is just going to be in words. So we might say something like, y is twice x. And so that would be the same as saying y equals 2x. So we would just say it in words, a verbal description of it. Okay? An equation is an equation. We know about those. 3x minus 2. Just has an equal sign, has numbers, letters on each side. Standard function notations means we replace the y with these things. So we would say something like f of x equals 3 times x minus 2. Or we could even say g of x equals 2x squared. Okay, so we'd use this special notation. And then a graph, we know what a graph looks like. A graph could be anything like this. Okay, make sure you bring these in on 10/23, which is Thursday.